Hi friends, in this series we are deploying AI agents to different services from GCP, AWS and Azure. Previously we have deployed containerized applications and functions to GCP Cloud Run and Cloud Functions. Today we deploy agents to GCP App Engine. Alright, the Cloud Run and Cloud Functions, these are serverless, whereas GCP App Engine, it's a PaaS, platform as a service. Now all three are fully managed by GCP. Now the main difference is to GCP App Engine, we deploy more of a full-fledged web applications, mobile backends, etc. The Cloud Functions is the simplest among three, and also it can carry out only a very lightweight works. Okay, it's a single purpose functions. All right, the Cloud Run is in between Cloud Functions and App Engine. Okay, so here is a summary from ChatGPT, pretty accurate, and it cover all the important aspects and distinctions. Okay, let's look at this best for, right? So the Cloud Run, it's for these APIs, microservices, and also we deploy the containerized images, right, to Cloud Run. Whereas to the Cloud Functions, we deploy code as it is, mostly a single function. Okay, so it's event-driven tasks, lightweight APIs, and automation. It's mostly for this tasks within the cloud service, right? The responding to pops up events, maybe some changes to the files in storage buckets, things like that, right? Whereas App Engine, we have the full-fledged web applications, mobile backends, having multiple services. Okay, all right, and also all three are managed by GCP, so we don't have to worry about the scaling, the security, keeping the service up and running, etc., etc. But since these two are serverless, we get charged only for the compute time, whereas App Engine, we have a dedicated instance, so we get billed 24/7. All right. Okay, so yeah, we are in the GCP App Engine folder. Now we have our code in this app.py file. So it's the same code used for Cloud Run. For Cloud Functions, we had to change it because it's a function service. We remove all the FastAPI related stuff, the endpoints, etc., and we decorated the main function with GCP functions framework. Okay. Now the main difference coming to App Engine is here we need to specify how to run the application. So we need to include the main function and specify how to run the port and the host, etc. Okay, so this is the new part. All right, and then we need to create this app.yaml file. Some of it we have covered in the past videos. We define the port, we give the service a name, a runtime, Python 3.10, and the entry point. So our script name is app, file name, as well as our function name is also app, as you can see from here. And then so since it is a full web application development framework, we can configure the instance, more granular details of the instance, right? For example, how many, the maximum instance we can have when we have more traffic, depending on the CPU utilization and the throughput, right? And for each instance, we can configure the CPU, disk space, memory, etc., etc. Okay, and deploying it super easy. All we need to do is gcloud app deploy app.yaml file. Okay, so it expects at least two files, our application code, which in our case is simple app.py file, and also the requirements file. Okay, since we hard coded the connection to the database and OpenAI API key in this .env file, we copy that one as well. So only these three files. All right, so once we have everything set up and we'll authenticated the Google Cloud, we just need to run this single command, right? Gcloud app deploy app.yaml. Okay, so this is how it looks like. It gives you some configurations. Do you agree with that? And then yes, proceed. And once it deploy, it will give this URL. Okay, and then it also shows how we can see the logs as well as how we can open the app in the browser. Okay, so let's run this command. So by default, it should go to the route, the main route, which should display a message that our order tracking AI agent is up and running, which is here. Yeah, this one. That's the main route. And then we have an endpoint, a chat. Since it is an app engine, we can have as many services slash endpoints as we would like to have. Since it is a fast API application, we can also access the docs. Sorry, let me go here and run the command again. So we should be able to access the docs as well. All right, we have two endpoints. All right, now let's quickly test it from Fast API before we see how it looks like in the GCP console. Okay. All right. Let's test the route. So get request. This is the route, and it does not take any payload. So got it. So this should say our AI agent is up and running. Now let's make a post request. The endpoint is chat. This should give us the status of the order in a couple of seconds. So for the database, we are using free version on AWS. It's quite slow, but with better instance, we get the results much quicker. Okay, so here is the tracking ID, and it is expected to deliver on some 3rd September 2025. All right, now I'll quickly show you. If you don't want to use Postman, if you want to have a script quickly test it, you can either test via curl. Just need to change this URL, and here is the payload, and making a curl request. Okay, either you can run this bash script, or you can use the Python request library. Again, just change the endpoint, the payload, the headers, and we are invoking a post request. Okay. All right. Let's look at how it looks on GCP console. So as we saw before, the containerized applications, they reside here, gcr.io. So this is the artifact registry. It's a unified one for various services. When we deploy code, containers, etc., applications, all the artifacts are stored in the artifact registry. Now GCF, that's for cloud functions, where we deploy the code, and this is for app engine, GAE. Okay, so app engine, if you go here, we should have all our apps. The one which we just deployed, we have 2 versions of the app. You can go to any version, and from here also you can deploy it. Okay, all right. And then if we go to app engine, this is how it looks like. Here we have the app engine, the dashboard where we can monitor the request, the latency, the traffic, everything. But under the service, we should see our application, AIAgent app engine. We again have 2 versions. Now, similar to Cloud Run and Cloud Functions, here also we can have multiple versions of the app. We can split the traffic between them, etc. Okay, and what else? The source code, we have covered it. Only one thing is this app engine, before we deploy our own app, it expects some default app. So first go to settings and enable the applications. So since it is already enabled, so by first enable the app engine service, and then with just some deploy a dummy type of application which doesn't do anything. It expects this default application, and after that we can deploy our own applications. Now remember, with Cloud Run and Cloud Functions, those are serverless, so we don't get charged unless if we use them. Whereas App Engine, an instance is with configuration is dedicated for our application, so we get charged. So make sure if you are not using, you close or you delete your App Engine service. Okay, so we get charged for this F1 instance with these resources. Okay. All right, that's pretty much it. So with this, we have deployed our app to 3 services: Cloud Run, Cloud Functions, App Engine, and these are all fully managed by GCP. Now, if you want, we can deploy to the Compute Engine, GCE, Google Compute Engine, but that one is fully user managed, right? So maybe the security, updates, patching, the scaling, etc., everything has to be done by us, unlike the 3 services we just discussed. And if you want, we can also deploy to the Kubernetes engine, GKE, but the most complex one, if our application is too complex, we want to control over everything, you can go for GKE. But otherwise, for most applications, one of these 3 services like Cloud Functions, Cloud Run, and App Engine should work fine. With this, we have covered GCP, and next we cover either AWS or Azure. Okay. That's all for this video. If you find it helpful, please consider support and sharing in your network. Thank you very much.